Okay, I actually want to finish this problem because um, I want to show you how it's going to be graphed. So it was my bad that there was a quadratic formula here and I wasn't prepared for that. When you plug that into a calculator, you'll get your x value. So this should be 297 under the square root. Your x value should be x is equal to 3.18 and x is equal to 0.31. But this is where we cross the horizontal asymptote. So this all came from setting 1 equal to that function. So you have to look back at the previous video and see how I got to this step. Okay, so this is where we're crossing the horizontal asymptote. Now the reason why I want to continue this is because I want you to see the graph. If you're able to get these values, I think most of you were able to get the intercepts, the vertical asymptotes, the horizontal asymptotes, and whatnot. So now we're going to put it all together in the graph. So the graph should look like this. I have my graph, and I have my vertical asymptote at 0, and I have a vertical asymptote at 4. I know I have a horizontal asymptote at 1. And I know a couple of things. I know I don't have a y-intercept. I have 3 x-intercepts. So I'm going to intercept the graph, the x-axis, in 3 places. I'm going to intercept it at -2. I am going to intercept it at 1. And I'm going to intercept it at 3. I also know that I cross the horizontal asymptote at 3.18, and I also cross the x-asymptote at 0.31. So let's actually take a look and figure out what's happening in each of these places. So if I take r of 4, so I'm going to pick a test point, and let me plot r of, let's do r of 4. If I plug it into the original function, I'm going to get this is 4 minus 1 is 3. 4 plus 2 is, I actually can't plug in 4. I have to plug in 5. So let's do 5, because 4 is the vertical asymptote. So this is going to be 5 minus 1 is 4. 5 plus 2 is 7. And then 5 minus 3 is 2. And that's all over going to be all over 5 times 1. So at R5, I'm actually going to be at 56 over 5. 56 over 5 is around 10 point something. So at 5, I know I'm going to be all the way up here, which means I know my graph will go down like this. Now, at 4, for my original function, remember, 4 has even multiplicity. If it's even multiplicity, I know that this is going to go up. And look, that actually follows what happens here. So I know that I'm going to go through here, and then I have to go through here and through here. Those were all the points I got from my x-intercepts and crossing the horizontal asymptote. So what I know is that I'm going to go start up here, and I'm going to go down here, and then I have to loop back up. That's the only way this graph can occur. Okay. Now, if I want to be sure that's how my graph occurs, let's plug in a point like -1 on the left side, because I want to see what happens on the left side of the graph. If I plug in r of -1, I get -2, 1, -4, all over -1, times 25. Because negative 1 minus 4 is negative 5, and I square that, it's 25. So what I get is 8 over negative 25. So at negative 1, I'm right here. And that goes along with that x-intercept at negative 2. So I know my graph is going to go like this. And since I'm at odd multiplicity here, I know if it goes down here, I have to go up this way. So it does make sense that my graph is shaped in this fashion. Even multiplicity at 4, so my graph should go in the same direction at that vertical asymptote. And at 0, I'm at odd multiplicity, so I'm going in different directions. So that's how your graph should look like. On the test, I'm not going to give you where your horizontal asymptotes are going to be the quadratic formula, but I just wanted to show you that I do cross the horizontal asymptote at those 2 points. Okay. Now, the last problem, if you didn't come after school to my classroom, I actually said the last graphing question you can't do because you have an oblique asymptote. So, in this video, I'm actually going to give you a bonus problem, and I want you to try it, and then I'm going to go over it to see if you match the graph for this problem. So, what I'm going to give you is the function r of x is equal to x over x squared minus 4. So, if you want to try this on your own, I would pause the video and do this on your own. And then what I'm going to do is I'm actually going to work it out to see if you match the answer here. Okay, so the domain here, this simplifies to x over x plus 2, x minus 2. So my domain is all x such that x cannot equal negative 2 and x cannot equal 2. My y-intercept, I set x is equal to 0. And so my y-intercept is going to be 0, because if I put 0 at the x, it's going to be 0. My x-intercept is going to be 0. I set my y equal to 0. If I set y equal to 0, this is going to be 0 is equal to x, because I just care about the top. So my x-intercept is also 0. So I know I go to the point 0, 0. So that's A, that's part B. My vertical asymptotes for part C is when my denominator is equal to 0, so I know I have a vertical asymptote that x is equal to negative 2 and x is equal to 2. My horizontal asymptote, my degree on the bottom is bigger, so I know my horizontal asymptote is y equals 0. And then I have to check, do I cross the horizontal asymptote? Well, that's actually, I take the 0 and make it equal to this. So this is letter E. 0 is equal to x over x plus 2 times x minus 2. And we all know the answer from this, since we just did it with the x-intercept, that I will cross the horizontal asymptote at x is equal to 0. Okay, now we have all that information. So what I can do is now I can graph it. So here, if this is my graph, I have a vertical asymptote at 2. I have a vertical asymptote at negative 2. I have a horizontal asymptote at 0. I know I cross my horizontal asymptote at 0, and that's my x-intercept and y-intercept. So we have to check what happens here. If I plug in a number like 3, I'll get r of 3 is equal to 3 over 9 minus 4. And so r of 3 is equal to 3 over 5. So I know at 3, I'm at 3/5. So that means I'm going to go up this way, and I'm going to go up and continue down that way. Now, since this is odd multiplicity, right, because this was x plus 2, x minus 2, odd multiplicities, I know I'm going to go down here. And look, I'm going to actually cross my asymptote. So I think my graph will go up here and go through here. But let's just make sure. Let's plug in a point on the left side. Let's plug in r of negative 3. I'm going to do it right here. R of negative 3 is equal to negative 3 over 5. Because negative 3 squared is 9. 9 minus 4 is 5. So at negative 3, I'm at negative 3/5. And so it does follow that my graph here will have that shape. So it does make sense in the middle. Since these are odd multiplicities, I'm going to go up this way, I'm going to go down this way, and I'm going to cross my axis right there. So I'm going to go up, down into that curve that looks like that. So this is the graph for the bonus problem that I'm giving you right now.